Welcome to another discussion from Sound Approach. Today we have a very special guest from our partners at WireWorld to discuss our most popular selling brand. I'm happy to introduce David Salz, the owner and founder of WireWorld Cables. Welcome, David. Thanks for joining us today. We're happy to have you here to discuss your cables, and I think we should just dive right into questions.
Excellent.
You ready?
Well, I'm glad to be here and very happy to talk about what I do.
Fantastic. Well, let's start at the beginning. How did you first get started in the cable manufacturing process and the creation of WireWorld, and how did that shape your mission statement for the company both then and now?
So I started out as a music lover early in life,
Mm-hmm.
and by the time I was a teenager, I was involved in car stereo.
Yeah.
You know, my own car stereo, my friends' car stereos. I was doing installations in custom ways because
Okay.
I knew, a little bit about audio, and I was always trying to make things better.
How did you learn about that, all this stuff in audio? Was it just through experience playing around with different pieces of equipment?
That, and I would actually read about it.
Oh, okay.
So I used to visit, before the internet, I visited the library a lot.
All right.
So I love science
Yeah.
besides loving music, and so it all worked together. I'm also somebody who works with my hands a lot.
Okay.
I've always built things.
So that led to your love for cables and
Yeah, and of course, as I was involved in car stereo first as an amateur and then professionally, I learned more and more about audio, and eventually saw what was happening with cables
okay.
as products were introduced that were supposed to sound better, and I would try them. And that culminated in a point where I had a very good audiophile system,
Mm-hmm.
and I was trying to find the best interconnect between my amp and preamp.
Okay.
And I was able to, with some of the connections I had professionally in the car stereo industry, bring in some of what was supposed to be, everything I could find that was supposed to be a better cable.
Yeah.
And as I would swap these cables between the amp and preamp, things kept changing. But I was never convinced that any one of the cables was really much better than the others.
Okay. So they did different things, they had different sounds, but not necessarily better clarity or better sound quality.
Yeah, I mean, it didn't clearly sound more like live music with any of those cables.
Yeah. And was that your baseline? Were you trying to make it sound like live music?
Right, and I was very familiar with live music, with
Sure.
musicians in my family and friends and so on, and especially piano and acoustic guitar, which
Okay.
are both very difficult to reproduce.
Yeah.
And voice, of course.
And voice. The voice is
Yeah.
very difficult.
So I did an experiment.
Okay.
Of course, I was soldering and doing things like that all the time. I made the best very short back-to-back RCA plug adapters that I could make, and I stacked my preamp and amp on books so I could plug them in directly.
Yeah.
And instantly I heard more music.
Better sound.
The music was more expressive, it was more natural.
Yeah.
It was just a lot better than any of the cables.
So that was your light bulb moment.
Yeah, and I listened that way for a while, and then I realized, well, why aren't these people making these expensive cables getting close to that?
Yeah.
And then I realized that maybe they're not even testing.
Okay. Oh, see, that's the key here.
Because when you compare cables, you hear differences, but you don't really learn what a cable is losing.
No.
Which is the most important thing.
Or what's causing those differences.
Right.
Yeah.
And so I began testing, and I realized that there was a big opportunity
Mm-hmm.
to solve this problem for people. The experience I had was all of a sudden my system sounded more like music. It was much more enjoyable. And then, I just couldn't go back to the way it was.
Sure.
So it was very awkward, and I realized that I wanted to share the experience
Yeah.
of this much improved musical performance with other people.
So was that just with this is just still with the connector. So what
Right.
so you wanted to introduce cables into the system that had a similar sound?
Well, I wanted to learn. This was what I realized was that this was the development tool for learning how to make a cable really
Okay.
do what people wanted it to do, and that
Yeah.
is nothing. Because anything a cable does to change the sound seems to be taking away sound.
From the sound.
The subtlety, the expression, the
Mhm.
textures, the beauty of what live acoustic music sounds like.
Okay.
And even with electronic instruments, the completeness of the sound, the beauty.
And I take it that that methodology, that testing methodology, has continued throughout.
And expanded.
And expanded.
Absolutely, yeah. So I've never changed my methodology.
Okay.
I'm hearing exactly what I want a cable to do
Mhm.
before I design the cable.
Okay.
And I just don't know if anyone else designing cables goes through that
Takes
process.
that approach.
Yeah.
Yeah. Well, how has WireWorld changed since its inception?
Well, what happened in my development was that I learned of a design which was originated in Japan by Mogami
Okay.
in the 1970s, where they had thin tubular conductors, the positive on the inside, the negative on the outside, a type of coaxial, that solved some of the problems. And I started working with that and creating products, my own versions of it. I was trying to take it steps further, and I was able to.
Yeah.
And I stuck with that plan and various evolutions of what we call symmetrical coax. I coined the term symmetric coax when I filed a patent on how I had optimized that concept.
Okay.
But
different from the Mogami cable.
Right.
Yeah.
More optimized, but still the same concept, concentric tubes.
Sure.
So WireWorld started off with all of the products using that structure, and went on for quite a while. Since the company was founded in 1992, it was around 2010 when I finally realized a better way. Now, the background, of course, is that the signal moves through a cable with through electromagnetic interaction.
Yeah.
And the function known as eddy currents, and that is that some of the current is not flowing straight through
the cable,
but is moving in different directions, it becomes inefficient.
Sure.
And so eventually what I learned how to do was to have all of the strands completely parallel, in line with the flow, in a structure that was practical and allowed me to solve the other issues, shielding and having it low enough resistance and so on, and patented that design in 2013, and that is what we call the DNA helix.
And that's the current design.
Which is the structure we use in most of our cables.
Okay. Okay. Well, what is your methodology for developing upgrades or designing a new cable?
So systems have to be built that allow me to eliminate the cable.
Okay. Like that original test.
The original test, right. So for speaker cable, we would have monoamps directly coupled into the speakers. It's not quite as simple as it sounds. If you really want it to work the best, the amp can't be affected by the vibration and so on. And with those tests, it's very easy to hear what the cables lose.
Sure.
And what's changed. And the cables that make the most dramatic changes in the sound are actually the ones that lose the most quiet information. So this is, one of the interesting things about high-end audio is there is fidelity and there is style.
Yeah.
And what I really cared about was fidelity. And so my test was the way to learn what I needed to learn to keep moving things ahead.
Okay. So when you complete those tests, do you decide right there and then that you're going to go in a certain direction for a specific cable?
Well, there's a lot of refinement, that goes into a finished product. But basically, I work out, once you know the solution, then it's about applying it in practical ways to hit price ranges and applications that make sense for the end user.
Okay, that makes sense. So once development has been completed, what is the manufacturing process for WireWorld?
Well, it's very difficult to find factories that are willing to change the way they do things.
Because it's different than the way other companies do
Right.
things.
Because once I learned all the things that are going wrong, and in some cases, the things that create noise in cables, the processes in the factory level need to change. So basically, started off going with a factory in America that was literally the world's first, started in the 1800s, custom cable factory. And that was very good for me because they knew things I didn't know and so on. But where their limitations left off, that led me to find other factories.
Okay.
And it turns out that a factory in Taiwan, most of our interconnects and speaker cables are made there, has been the best that we could find in terms of availability of better materials and learning new techniques.
Okay. And their capability to build the existing design. Okay. Well, how has the technology for manufacturing cables evolved? Has that changed dramatically over the last 30,
Most of the
30
processes
years?
of cable manufacturing have not.
They haven't.
But the structures get more and more optimized for each thing that they do. Just like in networking, Ethernet cables get faster and faster and have to work with newer, better electronics and so on. We've had to follow a very similar path. But of course, interconnects and speaker cables and digital cables are mostly fairly standard formats.
Okay. Well, what can you tell us about the DNA helix technology currently being used by WireWorld? You touched a little bit on this already.
So if we look at the way a signal moves through a cable, is the electromagnetic field vibrates the electrons. We have a very good test that we do as a public demonstration to show people how critical this effect is. And that is that we call these demonstrations cable polygraphs. That's kind of what we've named the testing and so on. And we have amplifiers that plug directly into speakers. They're very easy to change cables or plug them in directly. And we start off direct, and that would be the equivalent of a cable that lost nothing and changed nothing.
Zero loss, zero signal.
Right. And we go to a 10-foot pair of 14-gauge zip cord, we lose quite a bit.
Yeah.
I mean, there's some coloration too, but mostly it's about the music is less alive, it's less dynamic, it's fuzzy, it's just not nearly as good. We go back to direct, instantly clarity.
See that difference.
Yeah, the image is much cleaner and tighter and focused, and the dynamics are better, and we can hear quiet things again.
Yeah.
Next, we take another pair of the same 14-gauge zip cord where we've pulled the conductors apart. The loss is dramatically more.
I would imagine
than before
so, because
we separated.
That definitely expands the
right, and this of course is logical. The signal
it
moves through electromagnetism, right? And what happens when you move magnets further apart?
They're not as strong.
They're weaker.
Yeah,
and so that is actually the whole basis for what we do. What we're really trying to do is go as far as we can in the opposite direction.
Sure.
To use the field as efficiently as possible. This is a measurable effect. If we put high-frequency test signals through the cable, they come through better.
You can test with different twists,
the cable
with different wraps, with
and
different insulations, all those things you can test to see the effect.
To see the effect, but what we hear tells us much more than what a scope can tell us. So even though we measure these things occasionally, it's not, the primary test is always the listening test.
Yeah.
You're hearing a very good music reproduction on a system where a cable has been eliminated, a primary cable, and then we insert cables.
Has there been any listening tests, and this is just off the top of my head, but have there been any listening tests that surprised you, where you didn't expect the outcome that you got, where you're like, wow, that's either way better or way worse than I expected?
Well, what we've learned really follows conventional physics.
Okay. So nothing.
When we reduce triboelectric noise in interconnects and digital cables, the sound is always cleaner and there's more information. When we make a speaker cable more efficient, there's less difference between it and the direct connection.
Okay.
There are things that physics doesn't seem to explain completely, as in, well, we make a power cord that solves lots of problems.
Yeah.
And when we use a better conductor material, it does that better. Well, the power cord's a filter. It works because it prevents noise from getting mixed with the music.
And you're talking about the MSPS for that?
Well, all of our power cords, right? All of our power cords, but in fact, when we upgrade the conductor material, it works so much better. There's no clear explanation for that.
Why the conductor material makes
Would
so much a
be
difference.
if it's just a noise filter.
Yeah.
And so it's more complex than that. But the demonstration shows it very well.
Mm-hmm.
And the development for power cords, we're comparing to perfectly quiet battery power, which is always a little better.
Yeah.
No matter what. So it is a wonderful test.
Okay. Well, other proprietary technologies from WireWorld are the Unipath design, the flux field design, and the silver 2 plugs. What separates these technologies from other cable manufacturers, and how do they improve cable or sound quality?
So when I started out, I was always looking for ways to make better connections with lower loss.
Mm-hmm.
And, you know, I had one realization that I ended up patenting that was very valuable. And that was that I could create a connector that uses a silicone rubber ring to provide the tension on an RCA plug ground.
Okay.
And with that technique, we were able to achieve a much lower resistance in that connection. So that is one of the key issues to preventing problems in a cable, is having the best possible connection. I even went through the trouble of having some of these machined out of solid silver for a number of years, which was extremely difficult.
And expensive, I imagine.
And expensive. and so thankfully, after a while, I realized that I can make the parts in copper and put a thick plating of silver on them. And using our technique, we've achieved the lowest contact resistance of any RCA plug in the world.
Wow.
So, but in terms of a development process, you know, that was a simple realization once I knew the mechanics of how the plug
So it kind of
would work.
evolved naturally.
Right.
Yeah.
But there are other development processes that I'm more proud of.
Yeah.
Because I learned so much more about the process itself.
Okay.
And that in particular are the flat power cords that we've been making for over a decade.
Yeah.
Which are extremely effective at solving the problems of noise, getting into the components, mixing with the music.
And we've had clients reach out to us and say that that power cable makes such a dramatic difference sometimes. Just upgrading from the one that they got in the box with the piece of equipment from the manufacturer, and upgrading that cable can make a huge, huge difference.
Absolutely. You know, the power we get from the wall is alternating current, and it's noisy.
Yeah.
And there are reflections and harmonic frequencies happening just because that this is a very complex
and
connection.
RF interference and EM interference from the other
all
pieces
kinds of
equipment,
interference,
all sorts of stuff that can enter through that spot.
And so having a power cord that filters that and prevents it from mixing with the music.
Yeah.
And of course, you know, one of the things you have to understand to appreciate this is that it's almost impossible to take that noisy signal and turn it into perfectly quiet direct current. And that's one of the reasons a lot of components get so expensive, is trying to build a power supply that can do that is costly.
Yeah.
So this process was different than anything I had done, because I ended up with a whole list of features that the product needed to have.
Yeah.
To really fulfill that goal.
Okay.
And it turned out it was a very complex design. Thankfully, we've gotten very good at manufacturing it. But it's often the first thing that we like to demonstrate for people to show what our technology can do.
Is the power cable.
Is the power cord, because it cleans up the sound so much.
Yeah. And they're power conditioning cords.
Right. We call them power conditioning cords. Now, the concept here, we're strong believers in power conditioning. In a power conditioning cord, the job of it is to extend all of the functions and benefits of power conditioning all the way into the component.
Okay. So it sounds like this is one of your favorite pieces of equipment, but are there any products or projects that you're particularly proud of that have happened over the years? I'm sure there are lots.
You know, that's a standout, but just the realization that I could come up with a structure that would satisfy more electrical requirements than others in the DNA helix, you know, since that's the foundation of so many of our products, that's probably number one.
Okay. Well, WireWorld is known for using high-quality materials in their cable builds. Can you explain why using certain materials is so important and what impact it has on the sound quality?
Well, signal cables, whether they be analog or digital interconnects, are subject to a lot of problems from noise. And so in the conventional way of looking at it, we're mostly concerned with shielding, but there's really a lot more going on.
Yeah.
And so musicians are generally familiar with what happens with instrument cable or guitar cables in particular, and microphone cables. You can touch them and make sound.
It makes sound, yeah.
And that's called triboelectric noise. Basically, there's static charges between the insulator or between insulators and conductors that generate signal. And it's mostly thought of as a signal that's generated by vibration and movement. But what I've learned is it's more than that, and that the signal going through the cable actually makes the cable create noise also.
So the signal moving, is it like a static generation of
Right.
the signal moving through the conductive material?
Yeah. It's a kind of static discharge charge. It's just everything is imperfect along the way.
Okay.
And that these charges are getting dissipated.
Is that an imbalance of like the electrons against the protons of the material or something?
Yeah, but if you look up
sure
triboelectrics,
yeah.
there's the publications on this basically match positive and negative charges in different materials, and the charge differential is a key issue in terms of
understood.
But it's static electricity.
Static electricity.
Just like you get on a balloon.
Noise interference.
Right.
And that's the difficult thing to.
That's been very difficult, and it's been a subject of quite a bit of my work. Now we have a technology we call Composilex to deal with this. So Composilex,
and that's the latest generation insulation.
Well, this is a whole series of unique ways of combining materials to reduce that noise.
Got it.
But composite dielectric technology is the long version of that. So making cables quieter really helps preserve the signal.
Okay. And that leads right into my next question. So the chase for pure signal seems to be an unending task. Do you think it's a solvable task, or is it approaching pure signal?
You know, the funny thing is, in each generation of product that I produce, it takes a lot for me to be satisfied with the improvement.
Mm-hmm.
And it also requires that my testing improve.
Yeah.
Because I'm constantly trying to listen for what's going wrong and make changes to get back to the original signal before it went through the cable.
Sure.
So, but what ends up happening is in between the time of the next improvement is I've gotten better at testing. And it's easier to hear what was going wrong.
To see what that
right. And I've listened to it for a long time, so I know the difference between the original signal and what comes out of the cable better.
Okay.
So yes, that does help me continue to make improvements.
So these are some of the steps that you take every day in trying to prevent interference and approach that goal of just pure signal along a length of cable. It's so interesting to get your input on this as the designer behind these cables and to understand what your process is. But I did want to ask about something else that's unrelated to the cables. Can you please tell us about your green initiative and what that entails?
We've been working on this for a while, and we've recently learned how to go further than we have in the past, but by utilizing, for instance, inks that are not poison and simpler packaging, we are able to reduce the effect of all the packaging that goes to waste in our society.
Okay.
Now, we have a tree planting program where we contribute to the greening of the world.
Yeah.
Which we know is helpful. But as we're going further this year, we are extending it significantly further in terms of packaging with no plastic at all.
Yeah. Oh, no plastic at all. So it's going to be completely recycled materials.
Yeah, most of our packages will be 100% plastic free.
Oh, wonderful. Well, that is a big step. That's a change from previous years. All right. Well, when you think about the future, what do you see on the horizon for cable development in general and for WireWorld specifically?
Well, of course, high-speed digital technology, continues to move ahead. Audio requirements are generally not near the leading edge of that. but video is.
What video is. Okay.
And when it came to running long length video cables at the new HDMI standard of 48 gigabits per second, which is really an extreme data rate,
Yeah.
we really needed to learn some new things. And for long distance HDMI connections, cables are now optical. They're called hybrid optical cables because there's some copper conductors in there for the 5-volt lead and so on. And so to make a better optical cable really required a lot of development, finding the best chipsets, lasers, and then learning how to build a better cable to work with them. And then I went a step beyond that and found a way to actually reduce the noise inside all the processing at the ends of the cable.
At each connector end?
Yeah.
Within the connector?
Yeah. Besides upgrading the cable and picking the best parts in there.
Yeah.
We call that technology Vivid Tech. It is exclusive to WireWorld.
Okay.
And it was actually necessary to get picture quality that was as good as we can get in our short, conventional copper,
Sure.
they say, but copper and silver in our case,
Okay.
HDMI cables.
Fantastic.
And we were very thrilled recently to be the first HDMI cable to be reviewed by a certified expert to actually improve the picture and the sound quality.
And the picture is what gets me, because that's one thing that's very hard to say. That it
Right, because digital video is already wonderful.
Yeah. It's already good.
So it's very good,
Yeah.
but it turned out that there's a significant level of noise, enough to create extra pixels that are not what they should be.
That are not within the actual signal.
Yeah, and it's called pixel noise.
Yeah.
And so with this noise reduction system, we're able to significantly reduce the pixel noise, which is already low.
Sure.
But we reduced it so much that even from a distance, you'll see a sharper picture. You'll see a little bit more saturated colors. There'll be a better sense of 3 dimensions.
And contrast as well.
And it shows up in contrast.
Yeah.
But, some of these things, yes, I can get a contrast change for adjustment, but it's not really the same.
Okay.
Because then you see more problems on the edges. And with our improvement in contrast, we're cleaning up the edges.
So
images.
So we've seen this improvement in this in the digital signals. What about the analog signals?
Well, obviously audio equipment gets better.
Yeah.
Over time. There are more and more speakers that produce, what I feel is a high level of resolution. And so the problems caused by most cables and most, I'm going to include most high-end cables of these sound effects that cover the music, it's more noticeable than it used to be.
Yeah.
And as soon as we clear up those problems, you really start to hear what these better components can do.
It's more noticeable because the components are
they're cleaner.
Yeah.
Tweeters are cleaner. Everything is improved, and that makes the cables more critical than they've ever been before.
Which is fantastic, because that means there's a role for people like WireWorld or brands like WireWorld to improve those signals and capitalize on the improvements to all the other components that are in electronics nowadays.
Absolutely.
David, thank you for joining us to discuss WireWorld and the technology and methodology that goes into the production of your cables. It's been wonderful to sit down with you and discuss these topics, and we wish you all the best for the future.
Thank you for that and the opportunity.
Absolutely. It's been a pleasure to have you here. So for more information about WireWorld Cables or to purchase your own cables, please visit our website at soundapproach.com and be sure to subscribe for our future content as well. So thank you all and take care.